In the next part of lesson 2.4, we're going to start solving systems of linear equations using the elimination method. Now, sometimes this is called the addition method in other books. They call it the elimination here. So if I say the addition method or the elimination method, you know what I'm talking about. Now, basically, this method is really nice when both equations are in that standard form we mentioned in the last part of 2.4. So if they're in standard form, meaning the x and then the y and then the equal and then a number, if we're in this sort of form, then elimination is really nice. Now, essentially what elimination does is it solves for each variable one at a time. So we're going to take two equations and we're going to add them in a certain specific way. And then when we add them, one variable pops out and we can solve for that variable. So we add these equations in order to eliminate a variable. So let's look at this example 1. We have 4x plus 2y is equal to 14. That's the first equation. And the second equation in the system is 3x minus 2y equals 7. Now, this one is a really nice system for elimination. Not only are we lined up the x's, the y's, the equal signs, and the constants, but also these two terms here, the positive 2y and the negative 2y, are opposites of one another. And basically, that's the first two steps. Whenever you're dealing with the elimination method, the first step is to make sure things line up. What we mean by that is that the x's, the y's, the equal signs, and the constants are all in alignment, I should say. And then we want to make sure our terms, at least one pair of terms, are opposites. In this case, the terms with the y's are opposites. So I can add up these two equations. Let me actually go ahead and do that on the Word document. So we have this Word document here, and what we're going to do, we have the x's, the y's, the equal signs, and the constants all in alignment. So we're going to take these two equations and add them up. Again, we need to make sure that our terms, in this case, the terms with the y's on them, are opposites. We basically either need to have the x terms be opposites or the y terms be opposites. In this case, we have the y terms be opposites. So 4x and 3x add to make 7x. 2y and minus 2y, when you add them up, cancel each other out. So they've eliminated each other. That's why this method is called the elimination method. We're eliminating these terms. And how are we eliminating? Well, we're eliminating them by adding the two equations together. That's also why some books refer to this as the addition method, right? Adding two equations together versus we're eliminating a term. So when we add those up, we end up with 0 y's. I can leave that off. The equal sign needs to be aligned. And then when I add 14 and 7, I get 21. Now notice what I've done. Since I've eliminated the terms with the y's, all I have is a single variable x. So I have 7x equals 21. I can divide both sides by a 7 in order to solve for x. Now we get x equals 3. All right, so that's what's going on. Now, once I've figured this out, again, let me go through this. We get 7x equals 21. When we added it, we divided by 7, we got x equals 3. Now that I figured this out, x equals 3, well, now I can plug in 3 in for this x or in for this x and solve for the y. So in order to figure out what y is, the y value is, I'm going to take one of my equations. I guess I'll choose the top one, although you could have chose either one. We're going to take 4 times x plus 2y equals 14, that top equation, and we're going to replace the x in it with the number 3. Now we can solve this equation. 4 times 3 is 12, plus 2y is equal to 14. Subtract 12 from both sides, we get 2y is equal to 2. When you divide by 2 on both sides, you end up with y equaling 1. Now notice what we've done. We've come out with an x value and we've come out with a y value. So we know the solution to this system of linear equations needs to be the point 3, 1. All right, so the solution would be the point 3, 1. And that's how we go about the elimination method. All right, you can see how the answer is written here. Now the question becomes a little bit more interesting when we do not have terms which are opposites. Now I'm going to skip this example too because it has a typo in it. It goes from 2y in the first question here, right there, to 2x. So I'm going to skip it. I'm going to do one of the cooperative group problems instead. This first one, does have opposites. There's a positive 1y and a negative 1y. Those are opposites. But notice when you go to the second problem, we get 3x plus y equals 16 and 2x minus 3y equals 7. 3x and 2x are not opposites. If I add these two equations together, I do not eliminate the x's. And right now, 1y and 3y, or negative 3y I should say, are not opposites either. So if you add these, we would not eliminate either the x's or the y's. So this is one where our system, although they're lined up, doesn't quite have opposites yet. So let me show you how to make the system have opposites. So here we go. 3x plus y equals 16, 2x minus 3y equals 7. Now the key thing here is to remember something we learned way back in chapter 1, and that is if you multiply or divide both sides of an equation by the same number, you don't change that equation. So that's what we're going to do. We're going to choose either the y's or the x's to eliminate. So what I'm going to do is I'm going to start by choosing the y's to eliminate. Okay? If you wanted to choose the x's, you could have done that as well, but I think in this case it's easier to choose the y's. Now notice what we have here. We have a 1 and we have a negative 3. This is a positive 1. I should probably positive 1 y and a negative 3. I don't like that color. Let's use a different color. Sorry about that. So we have a positive 1y here and a negative 3y here. So what we're going to do is on this top equation, in order to get the y's to be the same as the y's in the second equation, what we're going to end up doing is we're going to multiply both the left-hand side of the equation and the right-hand side of the equation by a certain number. Now that number is going to be, well, it's going to be related to this negative 3. I'll talk about what we're going to use in just a second, but let me just write 3 in for that one. And similarly, in the bottom equation, since the coefficient of the y of the top equation was 1, we're going to multiply the bottom equation by 1. Now here's the reason I chose a positive 3 rather than the negative 3. If I would have chosen a negative 3 here, if I would have done the exact same number as this coefficient, then we would have gotten -3 and a -3. We don't want that. We want a positive number in front of the y, a positive coefficient in front of our y, and also a negative coefficient. Hopefully that makes sense. So basically what we're going to do is I'm going to take the coefficient of the y in the first equation and multiply it by both sides of my second equation. And then I'm going to take the coefficient of the y of my second equation and multiply it by both sides of the first equation. Now, again, we want to officially, you want to change one of the signs. So this was a +1 and this was a -3. We needed to change one of the signs. It's usually easier to change the -3 to a positive. Again, if that doesn't make sense, we can go back and do another one after this. But, so the 3 comes from here. 3 times 3x is 9x. 3 times 1y is 3y. 3 times 16 is 48. 1 times 2x is 2x. 1 times -3y is -3y. 1 times 7 is 7. Now notice what happened. Now my coefficient of y in the first equation is a +3. Coefficient of y in the second equation is -3. Now I can add these two lines up in order to eliminate one of my variables. If I do that, 9x plus 2x becomes 11x. 3y minus 3y becomes 0. 48 plus 7 is 55. Divide both sides by 11. We end up with x being equal to 5. And just like in the last problem, we're going to go back up here, take one of my equations, it doesn't matter which one, I'm going to choose the first one, which was 3x plus 1y equals 16. And I'm going to plug in x equals 5. And then solve. If you solve, this becomes 15. Subtract 15 from both sides. You end up with y equals 1. So the solution here is the 0.51. All right. So if you ever don't have opposite coefficients on one of my variables, what I do is I take the coefficient, move it down, the other coefficient, move it up, and then multiply both sides. One of these coefficients we have to change the sign of. In this case, I changed the sign of the -3 to be a +3. I'm going to stop the video here, but we're going to do a couple more examples in another video if you need it.